In this problem, we're asked to determine whether the reaction is in equilibrium, and if not, which direction the reaction will proceed to reach it. So the way that we can figure this problem out is, and we're given that the equilibrium constant is 3. So the way that we can solve this is we can, from the information that we have, the snapshot of where the reaction is at this moment, we can calculate the QC and compare it to the KC, and if the reaction quotient equals the equilibrium constant, then we'll know that the system is in equilibrium, and if not, then we'll go from there. So to find the concentrations, we know that the volume is 1, and we know that the concentration is mass over volume, so part over 1. So we have 10 over 1, 18 over 1, and 24 over 1. So the numbers that are counted from the picture just end up being their concentrations. And we know that the reaction that's taking place is the reds plus the blues yield red blues, these things. And we know that the QC, which is the reaction quotient, is the concentration of products over the concentration of reactants times each other. So we have that the reaction quotient equals the products of reactants 10 over 24 times 18. So you get that the reaction quotient, is 0.02314848. And we can compare this to our equilibrium constant, which we know to be 3. We see that it is smaller than the equilibrium constant, so it's not in equilibrium. And we know that when the reaction quotient is less than the equilibrium constant, the reaction goes forward to create more products to establish equilibrium. We can also know this by looking at our initial concentration, or the concentrations that we have over here. We have a lot of the reactants and not many products, so we can see that the reactants are going to react to form more products.